Python scripting in the Unreal Engine. This time we're going to create an asset duplicator that will duplicate the selected item several times. For example, if we select this new material and we run our script, we want to have several copies of it. So going back to the Python script, we start by importing Unreal into our scope. Then creating instance of our Unreal classes. This time we're going to use the editor utility library. And once we've done that, we will get the selected assets from the user. We will again use the length of our selected assets in another variable called numAssets. And the last element we want to create here is the number of copies, which will tell our script how many times to duplicate the selected assets. Using a for each loop to iterate over the assets, we can then get the name of each asset and the path to be duplicated. We'll use the getFname method to get the asset name, and for the asset path we need to use another library. Since we're dealing with assets here, we need to get the editor asset library in place. The library has a method called getPathName for loaded asset, and this method only takes one parameter, which is the loaded asset. And since we're iterating over each of our selected assets, we can just use asset here. Since we haven't created an instance of the editor asset library, we need to do that in our section about instances of Unreal classes. Once we have our asset path in place, we can use the os.path.dirname method to get the parent directory of the currently given asset path. And of course, since OS is not imported into the scope yet, we have to add the import statement here. For the asset duplication, we can use a simple for loop. Before we get into actually duplicating assets, we just want to put a log statement here to make sure and validate that our script is working correctly. Switching over to the Unreal Engine, we can execute our script. And here we can see that we get an error that tells us that we're using the asset name object instead of a simple string. So what you can do here to just print it is to format our string and give it the asset name and the current index. Switching back to the Unreal Engine, we can then rerun our script and check our output. This time everything seems to be working fine, so we can continue with the actual logic of duplicating our assets. So let's switch back to VS Code, and instead of just printing it, let's put this name into a variable. To duplicate assets, we will use the editor asset library again. If we switch over to the documentation about the editor asset library, we can find the method that is called duplicate asset. And if we check the parameters, we can see that we get a source asset path and a destination asset path. So we just have to provide two strings. So let's create a new variable called destination path that's built from the source path and the current new name. The duplicate asset method gives us back an object of the duplicated item. So if we call the duplicate asset method with our asset path and the destination path, we will get back an object reference to the newly created object. We can then use this object to check against a non-type to determine whether the duplicate has been created or not. In that case, let's give the user an error, or more like a warning that the asset couldn't be duplicated. As the last step before checking our script in the Unreal Engine, let's add some logging for both the warning and the final statement that will tell us how many duplicates have been created. Switching back to the Unreal Engine, we can finally try out our script again. This time we can see that the new material has been created 5 times. If we go back to our script and crank up the number of copies we want to have, we can observe an increase in runtime. In order to measure how long our execution took, we will import the time library into our scope. We will create a start time at the beginning of the script, and once everything has been executed, we will create an end time. We could do a lot more with this timing information, but for now we just want to append it to our logging statement at the end of the script. So let's switch back to our Unreal Engine and re-execute the script, this time creating 50 copies. Checking the logs, we can see that the execution took 1.4 seconds, which is pretty fast. For even longer running processes, Unreal Engine offers us this slow operations dialog, which will give us an indication on how many elements have been processed and what percentage of the task has already been finished. So let's add that to our script. This is pretty simple. We simply have to get a total number of elements that will be copied. In our case, this will be the number of assets times the number of copies. In addition to that, we want to put a text label on top of our dialog to display the user what is going to happen. And we also want to have a label whether the execution is still running or not, since we can cancel it. This scoped slow task is wrapped into a context manager, which makes it really easy to use. We will pass it the two variables that we just created, the total number of copies and the text label. Once we've done that, we will just indent the rest of our code to get the indentation right, and then trigger the displaying of this dialog with a make dialog method. We only need to add two more elements to our script. One is the check for the user cancelling, and the other is the progression of the bar, depending on how many elements have been processed already. Back in our code, let's use the check to determine whether the user has clicked the cancel button. If he did, we want to set the running flag to false and break the loop. And here we can see why we need this running flag, since the break will only break the inner loop, but we want to exit the whole execution. The last step is to progress our bar, and then we can switch back to the Unreal Engine, select two elements this time, and let our script run for a second. We can see that the dialog is nicely showing the progress of our execution, and here we can see that we got the copies of all of our elements. The scoped slow task can get really handy for long running processes. This finalizes our Duplicator script.